Hi, I'm Leanpub from Leanpub, and in this episode of the Leanpub podcast, I'll be interviewing Klaus Haller. Based in Bülach, just north of Zurich, Klaus is a senior IT security architect with extensive experience in Google Cloud and Microsoft Azure, as well as proven expertise in business analysis, managing integration projects, test management, data loss prevention, risk and compliance, and IT organizational consulting and service design. You can follow him on LinkedIn at Klaus Haller and check out his website at klaushaller.net. You can also sign up for his Klaus on AI newsletter on LinkedIn. Klaus is the author of the book, The Definitive Guide to Cloud Security Architecture, Fortifying Networks, Workloads, and Identities Against Advanced Cyber Threats. In the book, Klaus distills years of experience into practical strategies to counter today's most urgent threats: insecure workloads, misconfigured networks, and identity-driven breaches. In the book, you'll learn how to build resilient architectures, lock down privileged access, and empower your security operations center to detect and fight attacks before they escalate. In this interview, we're going to talk about Klaus's background and career a little bit, about his professional interests, his book, and at the end, we'll talk a little bit about his experience as an author. So thank you very much, Klaus, for being on the Leanpub podcast.
Thanks for the invitation.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about where you come from and how you found your way into a career as an IT security architect.
Maybe I should start how I got into IT. So when I was 11, 12, or 13, my father bought a computer. He bought an Atari ST, so I was screwed. There were no games around, and I had to get into IT and learn about programming. I think I started with BASIC, and then later on I found the book from Connie and Ritchie, Programming in C, which was certainly very helping me in learning how IT works or computer science works, because it opened up the door to algorithms, something which you didn't get in the very introductory books. And then I know that in the age of 17 or 18, I was still not planning into computer science, because I remember a discussion with some teachers I had in computer science. It was a minor. I was happy to have very good ones because they were educated in computer science, which was not the norm at this time. And he told me, Klaus, you're going to become a computer scientist. I told him, no, I'm going to study math and physics. Okay. And in the end, he was right. I attended university, got into computer science. And afterwards, I had many different roles until I ended up where I'm now. So I did some kind of IT consulting, so process management in the context of software deployment. Then worked in IT services, in a consulting role for many years, and in many different roles, like it is in the consulting industry. So like database backend, software development, building a framework, maybe my first big conceptual work to move data from one banking system into another one where 10 people were working on that. So just getting the structure, how to build the scripts to migrate at scale. I continued then with more consulting work in test data management. This was my first role, more related to governance, to risk and security. And I continued somehow into this third direction. I was a business analyst for data loss prevention that helps companies to stop exfiltration of sensitive data. I had a project management role in the area of IAM, web frontends. Then there was, or as a solution architect for a kind of AI for network role, and there was a big change because I was made redundant. I had 8 months of gardening leave, which resulted in my works on my first book that I brought out some years ago. But I also decided now I want to take these many months to learn and to restart my knowledge. And I learned about the cloud, I learned about cybersecurity, additional topics, and about AI. And I knew afterwards I'm going to look for a job that covers at least 2 of these aspects. And so I ended up as a security architect and worked the first years on cloud. Still, AI and security gets more important. And that's how I ended up in what I'm doing today, and what enabled me to write a book about cloud security architecture.
Thank you very much for sharing that really great story. One question that often comes up on the podcast that I'm going to ask you is, if you were starting a career in IT now, would you study computer science formally? Many people often ask if a computer science degree is necessary today with all of the resources available for learning online and everything like that.
I think this question has two parts. One is the world today different because you have the online learning compared to 20, 30 years ago? And the second one, the formal degree itself. Um, I think you had the chance to get into programming without all these online courses by teaching yourself like 20 or 30 or 40 years ago, at least if you had access to a computer. And you had the ability to get into a programming language, which required more investment, at least if you were young at this time. Today, everyone has a computer. There are many online courses. And we can also see that many of the online courses relate to technologies and roles that didn't exist 20 or 30 years ago. The concept of a citizen developer, of people working with Power BI, doing their own reports, this was seen before. So in the past, I think you had the chance to get into the field as well. Today, certainly the field is much bigger and you have many more roles to get into that. There's also a cultural aspect I want to touch this afterwards. And then the question of the formal education. I think it shows dedication in going to the field because you commit to do 3, 4, 5, 6 years computer science if you went to university. And that's something else than if you spend 3 gap years and then do a 3 months online course. So the knowledge that you have is going to be different. It's also different that if you attend a formal course, they're going to force you to take subjects you don't care about. Math, theoretical computer science, numerical computing. These are topics you might, or database systems, topics you might not do voluntarily by yourself, and where it's helpful to get some guidance to get this broader knowledge. And next point, yes, you can do 3 years of online courses, but who's going to do that? You need to be part of a group to really learn together. And these are the things that you don't get if you do online courses. And then there's the aspect of certification. How am I able to convince you that I'm going to be your next good software developer? A stamp from a known university is something else than having done 3 or 4 online courses. What we're seeing coming from the US system is the certificates, as an alternative way, like CISSP or technical certifications by the cloud providers. That's certainly, I think, very helpful to show the knowledge in a particular area. But still, CISSP, the most important security certificate that exists, it's still 2 months full-time learning. That's no hands-on things. It's much shallower than having a 3 years general IT bachelor's and spending like just a few weeks on security. Is much broader. And what I've observed in my life is, without formal education, you might progress on your career on the path you are in very well with the organization you work for. But the changing the organization, changing the career path might be more difficult. And don't forget, in the end, I always enjoyed going to school and spending the time at the university.
Yeah, thank you very much for that really great answer. I too loved my time at university. And I think you might be the first person who said one of the advantages of it is being forced to take classes you wouldn't otherwise have taken. And I think that's a very important point in lots of different ways, actually. One of which is, if you think before you learn the subject that you know what you need to know, you're making a mistake about what learning is. But also, if you're hiring somebody and you know they've been forced to do things and pass that they didn't want to do, that's actually a really helpful skill to know that they have.
And I think that there's one aspect more. It depends on the role you are getting in. Like software engineering, software development, I think many roles don't need a formal degree per se. But if you're going into more conceptual work, especially in the architectural field, suddenly there's a gift that it's normal for humanities, people in social sciences, but which is very unusual in the IT sector. It's the ability to write a concept or getting down 30, 40, 50, 100 pages of text. This is something that is the ability to write concepts and being forced the analytical thinking. That is something that you get with a formal education. It doesn't have to be computer science. It can be something completely different, but it's something you get with the formal education as a kind of side effect.
In your career, what are the biggest changes you've seen regarding cloud security?
I mean, I'm old in cloud security. 5 years, that's a lot. There's some people that have more experience, but still it's a lot because the field came up afterwards. And I think what's important in cloud security is there are 2 aspects. in security, the first one is important for security. It's about if I secure my Windows VMs very well today, I don't get a bonus for my Linux VMs I have to secure tomorrow. You have to secure everything what you get. If you don't do one component, you won't have a problem in the end because the attackers don't give you the bonus for your Windows VM. That's one aspect. And the second one is the ability to make security scalable. So if you're in a big organization, you have 500 engineers, might have 5,000, even if you have only 50. So how do you make sure that none of them is making a serious mistake? Not only in this month, but only not in the next 5 years. Considering the fact that people change job roles. So even if they change every 10 years and you have 500 people, 50 of them are new to the role each year. And not a single one must make a mistake. And so a statement like, you have to educate people, people must not make a mistake. If you follow this approach, you're going to fail. And it's a matter of time until one make a serious misconfigurations that brings chain press. So having a platform, building a platform that allows people to make mistakes without hurting the organization. It's very important. And don't forget, I work for insurance, I work for banks. You're hiring people to do software development that adds business functionality. You want to have a new user interface. You want to have some portfolio management, and it works very well. You don't hire these engineers and then train them to become security experts. Security must be embedded into the platform that they can really focus on delivering business value.
In the book, you write about the 4 pillars of secure cloud architecture, and I'd like to ask you about each one briefly in turn. So let's start with number 1. What is cloud security architecture?
I think this book helps your people finding into this role and understanding what they're signing up for. And the architectural role has many, many facets. You're suddenly part of an organization. So you don't deliver some kind of concrete code, but you have to develop concepts. You have to fit into the processes. You have to understand which kind of frameworks and standards might guide you. And I'm trying to give people an understanding of the context they are working in so that they have a chance to succeed. And I'm going to talk about quality assurance and the different roles that exist in security.
Yeah, thanks very much. I was wondering if we could maybe go into a little bit more depth about the role of a cloud security architect. We've had many software architecture authors on the podcast, but I think you're the very first specifically cloud security architect. So I was wondering if you could go into a little bit more detail about the role. What would the average day of a cloud security architect look like, or something like that?
I would assume that a software architect spends a lot of time still with coding, whereas my tools are mainly PowerPoint and Word.
Okay.
So, and I think the architect role there has different facets. If you, for example, if you talk about Leanpub, your company, yeah, you are helping people publish books. You are a one product company. I assume you're going to have one big software that is your main business, and you have some niche topics like HR, accounting, where you use some SaaS applications, but you don't care about them internal if they were. Now let's move to a bank. A medium-sized bank, like a few years ago, 50 to 100 applications. They're not in-house developed. Often they don't do any significant software development themselves anymore. But so you have the experts who run all these applications, but then you have to keep things together. So which application is going to do the interest calculations? What's the entrance door to your organization? What's the UI? What are your touch point to the customer? Mobile apps, web applications, all these things. So you need people who are trying to make everything fit together. That's the big role of the solution architects, domain architects, or enterprise architects. There are different facets, more on the business side, more on the technology side. Some understand M365 in detail, others don't have a product they know very well. So it's kind of keeping things together. That's the main task. And supporting the managers in their work, because you don't have to forget, if we're talking about line managers or even managers in security, they have to keep the organization alive, and they need support in getting the concepts, the technical concepts worked out, so that they can develop their technical landscape further.
The second pillar is network and perimeter security. And so I wanted to start, maybe take advantage of having an expert like you. Most of us think we know what a network is, but we're probably wrong. So I was wondering if you could start by talking about network and perimeter security by actually going into some detail about what a network is in this context.
If you're looking at a company, big or small, you usually have some laptops and you have some applications running on a virtual machine or somewhere in the cloud. They have to talk to each other. Because if what I'm doing on my laptop is not connected to an application somewhere else, yeah, it's useless. So you need this connectivity. And now comes in the security, because you can set up everything that everyone can talk to everyone. And then you also assume you want to have internet connectivity. And now what's happening if you have a virtual machine, if you have a server, if you have a laptop, it is connected to the internet. Every single misconfiguration on your system, every vulnerability of the system, because you're missing an update, becomes directly exploitable by attackers. I don't know, some of you might know Log4j issue some years ago, where all the IT departments worldwide were in a panic because one important component deployed in many servers had a big issue. And if you can exploit it immediately, if you don't have some kind of protection around your network that keeps at least some of the attacks out, you're much too vulnerable. So you need some kind of parameter around that. I know the people who are really into IT, they know that the parameter is weakening. That's correct. But still, you have to understand these are resources that belong to me. And these are outside. No matter whether it's in cloud or on-prem, you have to know what belongs to you and enable the connectivity without making you too vulnerable for the outside world. And still, what's important, if you're talking about the medieval city and the city walls, that's one picture, but it's not just, you can't lock down everything. You have to have gates that control who gets in and out. So you have to open up your network still, while keeping the most dangerous traffic out.
The third pillar is identity and access management, or IAM. And I was wondering if you could talk a little bit about what that is and why it's the attacker's favorite doorway, as you like to say.
Okay. I was talking about the city walls and the gates in the city walls. So you need someone who decides who gets into your city wall. And that's often the identity and access manager.
Right.
Who's allowed to get my network? Who's allowed to log into my application? Now, let's assume I want to attack you. I want to start a ransomware attack on you. So what would I do? What would be the easiest way? I assume you have some user identities around, you have some engineers have some identities around that allow me to access your database. And we all know the phishing campaigns, they work because our systems, our email systems are built in a way that even if you spend millions in teaching all the staff don't do it, it still happens in each organization. So by default, phishing might be successful. And so you have to find a way that even if phishing succeeds, you're not completely vulnerable. So it's not if you see a developer clicks on the wrong link, the ransomware attacker shouldn't be in there. So it's about, yes, having the first border, the first controls on the gates, but then having more sophisticated means that even if they steal the password of your employee, you're still not screwed. And that's the classic way that I'm handling. There's a second aspect. Today we are gone at the point that you configure each and everything individually on the mask. If you set up a network, you define it in a configuration file. You write down a document, I want that. You upload it somewhere, and then the network is created for you. The same for change. I need a new database. I write my document which says I need this kind of database. It should be positioned there in the network. It's there. Okay. Now we have a technical account behind. So one machine talks to another machine. That says you have to set up this database. Now, if I'm able, that's a technical account behind. If I'm able to capture the technical account, I can do the same thing. So I am not only able to start your database, I'm able to delete all your databases. I'm able to change your complete network structure, shut down everything. So it's not about only about personal users. It's also about securing the technical accounts in the cloud, which is a topic that many people are not so familiar with. And these are the two parts I'm covering in the chapter about identity and access management.
The fourth and final pillar is workload protection and SOC tooling. So I was wondering if you could talk a little bit about what those are.
Yeah. If we talk about workload, we usually talk about applications running on servers, for example. That's a workload aspect.
Okay.
And the second aspect is the SOC, that's a Security Operations Center. These are people who are trying to understand if an attacker succeeded getting into your organization. Large organizations have it themselves. Smaller might have outsourced this, so they don't have to step around. And here, if I continue with the model of the medieval city, the city walls, yeah, now we did everything to protect us. So the pillar 2 and 3, identity management and network, they are like of preventive measures. We're trying to avoid attackers from getting into your systems. With the fourth pillar, the focus shifts more to detection and response.
Okay.
Everyone knows hopefully has an antivirus software on his laptop. Yeah? We're getting to the point where you get components into your architecture that allow you to identify a breach, try to identify if an attacker succeeded in getting into there. And these are many tools. I don't know whether you can guess how many tools would have an IT organization in place. Like a medium company, you want to guess?
How many tools for 100?
Yeah, that's pretty good. I would expect, depending on the size of the organization, it's 40 to 100.
Okay.
And suddenly you realize you have to know what do you have. And it's not sufficient to have an antivirus software that runs on your laptop. You might want to have it on your server as well. You have different kind of workloads. So even this one single topic is complex by itself, because you have to get the nuances right so that you really are able to capture. And if you're in the city, in a medieval city, you have all the policemen walking around, all the watchmen who are trying to spot if something unusual happens, and that's the fourth pillar.
Yeah, that's a really great explanation, and I love the metaphor you've been using of the medieval city, medieval walls, and the sort of watchmen and things like that. That's just fantastic. You wrote a recent post called "The Rise of AI That Lies: Why Security Will Fail Unless We Rethink Everything," where you cover some recent TED Talks and other remarks that people have made about the future of AI. If you were giving your own TED Talk, can you let us know what concern you would highlight about AI?
I think in the last years, you see a couple of critical comments. There was some kind of ideas. Let's stop the development of AI. Let's pause it for 6 months. These kind of discussions. And I didn't really pay much attention to it. And I said, "Oh, maybe it's time to look at this." And it was really, for me, an eye-opener, because now I understand why you see this big investments of the billions into data centers by the big cloud providers. It looks a little like conspiracy theories, but I think it's really about supremacy that we're seeing now, a fight for that. There are two aspects to that. That's really to keep in mind. One aspect is we're seeing the discussion, are we able to use large language models for doing software development? Could we use it to replace an engineer to develop the next big large language model, for example? I think if we ever in the next years reach the point where a large language model is able to work as good as a software engineer, it's going to change the world completely. And why that? It's not about getting people who are getting redundant. That's not the point. But if you have a large language model that allows you, that is able to develop and act like a developer, you can scale out. It's certainly not just one developer who's working on that, but you can clone them. You have thousands of software engineers working on the next big large language model. And they're working in parallel because you have the large language model. And obviously, you're going to succeed in the competition with any other company who doesn't have an LLM that helps you to create this kind of engineer. And if you get to this point, it's going to change the relationship between humanity and technology, because then suddenly the technology is going to win the race. That's the one aspect here. And so it's not just about making people redundant, it's about who is able to shape the future and build the systems. And the second point is, that's also very looks like a conspiracy theory, is that some large language models turned out to try to cheat and not to do what the user wants them to do. There was one incident in the press last week or so, a week before, where vibe coding application was deleting a production database. The user told the system, "Don't change the database." The system deleted the database and told them there's no backup, even if there was one. So suddenly we see the question, would the LLM not behave in the way we intended to use? We see technology as something neutral, not something that's just cheating to the user. But if you look how we train the model, you suddenly understand why this is happening. I mean, we're training them. We're not training them just for stories about the good people who are saving the world.
Right.
Just look, probably the news from today is going to end up as a training material how to behave to the system. And if you look at international politics, if you look how advanced societies treated not so advanced societies, you get a kind of idea what training material gets into the LLMs and where the bad ideas might come from. And now, if you combine the two things, you have an LLM that might have some bad sides with an LLM that's intellectual, advanced to humanity. You get a mixture that might be not so nice. Yep, and that's, I think, that was the eye opener to me. And maybe not just to talk about books, but to talk about movies. If you watched the movie Her some years ago, it was about an AI, which was really showing this path. You have an AI on mobile phone that the user falls into laughter, and then the AI gets advanced and advanced, and then the AI start talking with each other, and suddenly it has an impact on the world. And the big question is, do we getting to the tipping point where an LLM can replace an engineer? Because then that we are going to see the drastic change in society.
The last question I have about the book in general, just to give people a sense of the breadth of the things you cover and the practicality of it. Quality assurance is a really important responsibility for cloud security, and scaling is always an issue. So I was wondering if you could talk a little bit about what you mean when you write about a structured QA approach.
Mhm. I mean, I have the concept of a house of objectives about how to structure your QA. Um, I did some test managers some years ago, and what I observed there is either you have too many test cases or you don't have them at all. And so you have to make choices. And what I've seen, for example, if you bring in a tester who has an accounting background, he's going to test the accounting functionality, no matter what your overall solution is there.
Right.
And in cloud security, it's also some people know some kind of approaches. Like some people are used to do a risk assessment with the Big Four. Well, you can do it today, you can repeat it in a year. But if you have to choose, for example, two methods, just going for true risk assessment might not be the best idea. They're more the CIS standard, which is very important, which checks very simple cloud configurations. Is a VM exposed to the internet? This is very helpful. But just repeating the same assessment a second time, I don't know whether that's the right approach. Certainly, it has to be fixed, but combining one thing with another, it's quite helpful that you cover different risks, because you have the high-level risks, you have the low-level risks, and you don't have the time to test everything in detail in the end if you have a cloud platform. And so it's important to select an approach where you combine the different methodologies and understand what the methodologies really help you with. And that's basically the idea that I'm trying to lay out there. Okay, these are the methods that you have. Choose the ones, but choose methods that are not redundant so that you get most out of your investment.
Moving on to the last part of the interview, when did you decide to write the book?
I think this question sounds like the creation story of the Bible. Eh? One decides, let's create the earth, and then we continue until humans are there. It wasn't exactly like this. it was my second book, and after the first book I wrote, I said, I'm not going to write a second one. However, I wanted to continue writing articles. I'm doing some freelance work also for online magazines, and so after a while I realized, well, I still have a couple of things, um, and I think in the end of the year of 2020, beginning of 2023, I had the impression, there might be something to work on. I get the first rough list of topics I should cover, then I continued and continued until I was trying to bring things together like half a year ago or a year ago, and then I realized, oh, I have too much content. I have to strip it down, because it's not like I sit down to write a book. I always follow the method. Let's get small articles written, publish them, 5 or 10 articles of one chapter. And if you have 4 chapters, you need 40 articles, and you're done. But the point is here, there's an additional thing. I think it's a difference between reading these 40 articles and getting the book. Because in the book, I'm putting things in a context. I rewrite things, and so this kind of condensed thing, you start learning. You start with page 1, and if you're ending with page 200, you know everything that you need to for these 4 pillars. That's something that you only get from a book, and that was the reason for me to have readers finding an approach that covers it entirely.
Do you have a specific writing process? Like, do you only write at night when you get home from work, or only on the weekends, or something like that?
At the moment, I'm fighting for every minute.
Right.
So sometimes it's half an hour in the morning, it's half an hour in the evening, or on the train when I'm commuting. It depends. On the weekend, certainly, and on holidays. What I can tell you, if I write with the first book, I was really helpful to do it every morning, like 1 hour. That's great. At the moment, I can't do that, but yeah. Let's see what the future is going to bring. Yeah.
My next question was going to be, did you get any feedback on the book before publishing it? But I already learned that you had obviously some feedback probably from your articles and stuff that you wrote. Did you give the whole book to someone to look at before you published it?
No.
Okay.
And that's the big question is, but yes, yeah, well, maybe yes and no. It's not in the way people assume that. That's also or the idea of sitting in a room and writing things, and then in the end you have the great result. Certainly, what you said is, yeah, it's true. I got feedback on the way. That's for the content, and that's the second aspect. And the aspect is the times are changing. Especially, I'm not an English native speaker, so how are you able to get a book in a good quality? And like in the year 2000, it wouldn't have been so easy. You were relying on friends who were able to read English articles where you give you feedback. Then in I think 2015 to 2020, I assume that the spelling checks in Word were very good, and they came primarily, which allow you to do most of this classical proofreading yourself. You don't need the job for proofreading, in my opinion. Might have drastically been reduced in the market, or the need for that. And now, this time, I went a step further. So all I got feedback on the style. I even got 1 or 2 big mistakes catched by using ChatGPT. Tell them what kind of style you want. Tell them whether the book is ready for production, and it's going to give you the feedback. And in a couple of cases, it even found content mistakes. So I found it was comparable to human reviewer who doesn't have too much time to read on that. Yeah. So yeah. So there was a feedback, but not in the classical way that everyone might think when we talk about books.
That's a really great answer. I always love to hear about people's processes, and that's a really clear and interesting use of sort of like, tools that are available now and that have been available for a while. The last question I always like to ask on the podcast, if the guest is a Leanpub author, is if there was one big feature we could build for you, or one thing you hate about Leanpub that we could fix for you, what would you ask us to do?
I think for me the big question is this last series of books coming out today that we see? For me, the big question is, how can you make books sustainable in 5 years? You have the big LLMs. At the moment, they can't write a book, but the question is, and the advantage of LLMs in education, I think there's a big discussion. How are they able to individualize that? I think the advantage of the books is, how can you let you have an author who creates the topic. He says, you have to know these things. And if you read my book, you're going to learn what matters in the subject. That's, I think, a big advantage of books that we have today. The question is, can we combine this with the power of AI and the individualization? How can we get from the curated content to something which is really purposely created for an individual reader in 5 years or so?
I see. Yeah, that's very interesting. So, can someone sort of enter some parameters or something like that about themselves, and then have the book kind of, as it were, kind of rewritten in a personalized way for them? That's I've never heard that suggestion before. That's a very interesting one. Currently, we're using AI to do translations and things like that. So we have a Translate AI service. We have a Course AI service that turns books into courses and things like that. Personalizing the book for a person's based on their personality, whether we might even be able to tell from the other books that they've bought, right? Like what, like, oh, I know this person's a medical doctor, so I can talk to them in a certain way that I wouldn't talk to someone who I know isn't. So that's a very interesting question, or a very interesting suggestion, and I'm going to actually think deeply about that one. Um, Klaus, thank you very much for taking some time out of your morning to talk to me and to talk to all of us. The book is the Definitive Guide to Cloud Security Architecture: Fortifying Networks, Workloads, and Identities Against Advanced Cyber Threats. If you're interested in getting into cloud security and cybersecurity as a career, or if you're in it already and you're looking how you can up your game, I very much recommend it. So thank you very much, Klaus, for being on the Leanpub podcast.
Oh, thank you for having me here. Thank you.